Continuing talking about Mohr's circle from the combined loads handout that is put on your Moodle page. If you take a look at the Moodle page, there we go. The handout itself is right here, so you can print it out or have it available to you digitally, but that's what we're working from today. So for today, we're going to finish talking, we're not going to finish talking about Mohr's circle, we're going to do our last official Mohr's circle problem in class, and then Wednesday with lecture number 32, we're going to start talking about this more general case of combined loads. So let's come over here to the document camera, and I'm going to work directly from the handout. I had worked through a problem at one point last time, and I had also shown you that Mr. Bailey, who wrote these notes when he was working at the Air Force Academy, has a different sign convention for tau than we do, and I really want to just hang on. If you wish to do the other sign convention for tau, that's fine. However, it doesn't correspond with the right-hand rule, and it doesn't correspond with what you've learned in physics. So that's why I'm pretty committed to staying with the same sign convention. So I'm going to take a look at another problem. This is example 6.4 in your textbook, and we have a stress block, and we have designated a horizontal and a vertical face. We have on sigma x, we have a value of 1400 psi. The arrows are pulling out of the stress block, meaning that we are positive or in tension there. Now on the y faces, sigma y, we have 1000 psi. You notice that the arrows are pushing in. That means that they are in compression. So I just wanted to do this problem because the last one that we did, we had both of them in tension. So I just want to show you a little bit different, more circle execution when we have this particular configuration. So I'm going to come over here to the document cam, and the first thing I'm going to do is to redraw the stress block, and then we're going to run the steps and come up with our maximum values and also the orientation of the principal axis from the x or the y direction, from either the vertical or the horizontal face. All right. So on our stress block, the first thing is we have a value, sigma x here is 1400 psi, and sigma y, we see that we are in compression, so we can identify that value as being negative 1000 psi. Then we have our tau xy, which of course is a planar function, so that means that we have 4 arrows. The value is 500 psi, and because it's on a plane rather than on an axis, we have 2 different rotations. So this rotation is clockwise, this rotation is counterclockwise. That means when I identify the location of my vertical face, because this rotation is clockwise, this will be negative, and on my horizontal face, because this rotation is counterclockwise, that will be positive. All right, so I wish to find tau max. I wish to find sigma 1 and sigma 2, which are my principal stresses. In other words, the maximum value and the minimum value. And the other thing I want to do is to find the angle at which the principal stresses occur. So I'll have to draw this stress block with a line through it and an angle theta, or I can draw an x and a y axis with the block elevated or depressed from that particular xy coordinate system, sigma x, sigma y. Okay, so I'm going to do either one. I prefer to just draw it all on the stress block, but we'll go from there. All right, so the first thing we do is we go back to the steps for constructing Mohr's circle, which are right here on your handout. This would be on page 304. All right? So I'm going to go ahead and come back over here to the document cam and work out this problem. So the first step says find the stress block for the point of interest, which we have done. Designate one of the vertical faces V, designate one of the horizontal faces H. You could just as easily designate this V and this H. It does not matter. I just always, unless I have a good reason, I always use this face as a vertical face, this face as a horizontal face. But it's just a convention, just so that I don't do something in an unusual manner and then talk myself into doing it wrong halfway through the problem. So, but there's no reason beyond just organization to do it that way. Okay, the next thing we do is we draw the sigma tau coordinate system. So as you recall, even though this is horizontal and this is vertical, we are no longer discussing x and y. We are discussing sigma and tau. And as you recall, 2 degrees on my circle is 1 degree on the stress block. Horizontal and vertical are 90 degrees apart here, so they're 180 degrees apart here. Tau max occurs, we know from chapter 2, 45 degrees from the principal stresses, so 45 degrees on the stress block is 90 degrees on the circle. All's well. Okay, so the first thing we need to do, it says right now, Dr. Bailey, or Mr. Bailey, always says to write the coordinates for the V face and the H face, which I will write them down, but the first math I'm going to do is to find the center of the circle and the radius of the circle. Okay, let's go ahead and write my V face coordinates and my H face coordinates. Those coordinates are going to be in the form of sigma tau. So here on my vertical face, my sigma is 1400 psi. And as I said, this rotation is clockwise, so it's a negative 500 psi. On my horizontal face, I already know my tau is positive 500 psi because the rotation is counterclockwise, and my sigma y value is negative 1000 psi because it's in compression. Now these 2 points will be points on the circle that I construct on Mohr's circle. All right, so the first thing then, after I identify these points, is to find the center of the circle. The center is always going to be centered on here, right? Because where I have principal stresses, I'm going to have no tau. In other words, the value of tau is 0 at my principal stress. So for my center, the equation tells me that it's at sigma x plus sigma y over 2, comma 0. In this case, sigma x is 1400. Sigma y is negative 1000 divided by 2, comma 0. So the center of my circle then is at 400 divided by 2, which is 200 psi, comma 0. All right, now we need to do the radius. I'm deciding, I think, I'm going to just pull up another sheet of paper here. You can still see that. That's all that's important for now. We'll readjust this in just a moment. My radius, by formula, is just the radius of the circle, and that value is the quantity sigma x minus sigma y over 2, quantity squared, plus tau xy squared, the 0.5 root or square root of that entire quantity. So my sigma x is 1400 minus sigma y, which is minus a negative 1000, so plus 1000 over 2 plus tau xy. Okay, so since tau xy is squared, it doesn't matter if it's negative or positive, does it? Because a negative times a negative is a positive times a positive is a positive. So this is just 500 squared, and when I'm done with that, I'll take the square root of that sum of squares. All right, so I have 1400 plus 1000, which is 2400, divided by 2, quantity squared. This number is 1440000. 500 squared, I can do that one in my head, right? Not that hard. If I take those two numbers and add them together, take the square root of that sum. And then I say second square root, second answer equals. That number is, the radius of my circle is 1,300 psi. Now that's also going to be the value of sigma max, or tau max, isn't it?
I was looking at your team.
Okay, all right. So now the next thing I need to do is to know how to draw this circle, but let's find my sigma 1 and sigma 2. Sigma 1 is going to be the center value, 200, plus 1,300 psi, which is 1,500 psi. My sigma 2 is going to be the center value, 200, minus the radius, which is 1,300, or negative 1,100 psi. That means that my circle is going to be from 1,500 positive to negative 1,100 on my principal axis scale, and that my tau is going to be the radius, which is 1,300. That means that I need to make pretty small divisions in order to draw this circle. And so I'm probably going to go for 250 per division. So this is 0, 0. And if I go 250, 500, 250, 1,000, 250, 1,500, same thing here. Oops, I'm getting too big here, I'm getting carried away. Okay, so now remember my circle is not centered at 0, 0, it's centered at 200, 0. So it's centered about right here. And then I need to come out to 1,500 over this way, so 255,000, here's 1,500. That's the sigma 1. Over here, negative 1,100. It's about right here. And then my tau is 1,300, about right here, and negative about right here. All right, so then I attempt to draw a circle. That looks like this. And once again, it's kind of an egg. This time it looks like Mohrs football, but all right, there we go. So imagining that this is a circle, we know that sigma 1 is 1,500 psi. We know that sigma 2 is negative 1,100 psi. We know that tau max is 1,300 psi. So we have our preliminary information, but now we need to locate the vertical face and the horizontal face as points on this circle in order to determine the angle of rotation from the horizontal to the principal stresses or from the vertical to the principal stresses. So in order to do that, we look at those points. On my vertical face, my values are 1,400 and negative 500. Okay, so that means if this is 200, this is 250, so it's like this. 1,400, just a second. 500, so that point is like right here. Okay, so this is my vertical face, 1,400, negative 500. And on my horizontal face, it's at 1,000 and a positive 500. So it would be somewhere right here. The horizontal face, I'm sorry, it's a negative 1,000. See, I did that wrong. So here we go, 251 to like here and 500. There we go. So this is the horizontal face, which is negative 1,500. Okay, Now horizontal and vertical are 90 degrees apart. That means on the circle they're 180 degrees apart, and they go through the center of the circle. So the error in that drawing is due to my skill at drawing a circle, but the numbers are still correct. So then the question becomes, do we want to do a rotation from the principal stress to the vertical face, or the principal stress to the horizontal face? And I would say vertical because it's much closer. So that means when I rotate, I will choose from this face right here, and you'll notice that my rotation is counterclockwise. So that means that I will rotate counterclockwise to get my angle theta on the vertical, from the vertical face to the principal stresses. So now what I need to do is determine what this angle is. Okay, my x component, if you look at this triangle that's inscribed in the circle, I start at 200 and I end at 1400. So this is 1400 minus 200, which is 1200 in this direction. And I go from 0 to 500 right here. So my triangle looks like this: 1200, 500, and this is my angle on the circle. So using trigonometry, I have the opposite, and I have the adjacent side, which is tangent. So this is the inverse tangent of 500 over 1200. And so if I take that number, 500 divided by 1200, that is the inverse tangent. I need the inverse tangent of that number. Inverse tangent, inverse answer. Oh, no, do that again. Second tangent of 5 divided by 12 parentheses equals. Okay, so this angle on the circle is 22.6 degrees. That means that the angle on the circle we know is 2 degrees on the block. So that's, I take that value, 22.6, divide it by 2, and I get 11.31, or just 11.3 degrees on the stress block, which is right there. So I need to check to make sure from vertical to principal, from vertical to principal, 22 degrees, 13 degrees, and everything checks out. So this is the complete answer to a Mohrs circle problem. Okay, so it's all graphical, and you need to draw a circle and a stress block. You need to identify those things. You need to identify sigma 1 or sigma 1, sigma 2, principal stresses, tau max, and the angle of rotation from either your identified vertical face or your identified horizontal face to the axis of principal stress. Okay. Do you guys have any questions for me? All right, so what we're going to do is to break out the first part of the homework, and then on Wednesday we're going to come back and we're going to talk about combined loads, okay? And I'm looking at the homework at the end. We will end up doing all of these problems, okay? But 16.2, 16.3, 4, 5, and 6 are all for the second part, which I'll begin on Wednesday. So we need to do 16.7, 16.8, and we can't really do 9 or 10. But the homework then for tonight will be 16.7 and 16.8, and that will begin. Like I said, all of the homework is going to be, all of these problems will be assigned. So there are 12 problems altogether. So by the time we finish this section, all 12 will be assigned. But tonight it would be a really good idea to get started on 7 and 8. All right? So I'll post that up to our Moodle page. It will be ready for you. Hopefully at lectures 30 and 31 will be available to you, and I will, and then we'll come back on Wednesday and we'll start talking about combined loads. All right. So that's it for today. Thank you very much.